guys, today is a great day to talk about perpendicular lines. So let's get started. Two lines are perpendicular if they form right angles. That is the definition of perpendicular lines. Perpendicular lines are two lines that form actually four right angles. So if I have line L and line M like so, and if I'm given, remember we have to be given, we don't assume. So if we're given that these two lines are perpendicular, it would be written like this. It would be said as L is perpendicular to line M, and that would be the notation that you would see given to you. And what that means is that there's a line L and there's a line M, and they intersect in one point, of course, and that point of intersection where the two lines intersect forms four angles, and all of those angles are right angles. Definition. So we usually mark it like that because you always mark everything on a figure that you know to be true, that you're given or that you know to be true. So we know that I'm going to call that angle 1 just so I can refer to it easily, and I'll say angle 1 is a right angle. So if I am given this scenario here, the situation, and I want to think logically through it, this is the way my thought processes go. My first thinking would be to really look at what I'm given. I would be given line L perpendicular to line M, and that would be given. And this is, I'm writing this in the format that your two-column proofs use, just so that it establishes a comfort level. Not really writing a proof here. Okay, and then once I know that two lines are perpendicular for sure, then I know that the angles that are formed, and I'll just choose one of the angles this time. I'll say angle 1 is a right angle. I'm kind of squinching that in. I hope you can read that. Angle 1 is a right angle. And what I always put over here is the reason. How do I know for sure that that is true? Well, I know for sure because we just defined perpendicular lines to be two lines that form a right angle. So instead of writing out the whole definition, I can just write definition, I can abbreviate, of perpendicular. Excuse me. And that tells us that we have a right angle. And then our next logical thinking step, the way we want to start logically thinking our way through the problems or the proofs, is if we have a right angle, then we already know that that angle has a measure. So the measure of angle 1 would be 90 degrees. And we know that, and again, we put over here, how do we know that? We know that because we've already learned and understood the definition of a right angle. And so we know that the definition of right angles, and I abbreviate, and it's okay if you abbreviate, and again, you always follow the conventions or the methods that your teacher uses in class so that you're in sync there. But most likely it would be like so. So let's go through this again. If we're given two lines that are perpendicular, then we need to understand by definition what that means. And it means that those two lines form a right angle. So the next logical step would be to say, we could say any or all of those angles are right angles. So angle 1 is a right angle. How do we know? Definition of definition of perpendicular says that we have a right angle. So perpendicular, right angle, and then right angles measure 90. And how do we know that? We know it because the definition of right angle tells us that, and we've had that in a previous track already. So our thinking, if we think of it a little bit as a flow chart, our thinking would look like this. Our first step would be, I'll put this like a little bit of a flow chart. Our first step is we have perpendicular lines. What that leads us to is that we have right angles, or a right angle, whatever you need for your situation. And what that leads us to is we have 90 degrees. So this is the way our thinking proceeds. Perpendicular, right angle, 90 degrees. We don't skip that and go from perpendicular to 90 degrees. We go logically in step, perpendicular, right angle, 90 degrees. And that's almost every time you see perpendicular, your thinking will proceed in that manner. All right, now let's look at another definition. And this one is perpendicular bisector. We already know what perpendicular means now, and we already know what bisector means from a previous track also. We know that bisector is something that divides either an angle or a segment into two equal parts that have equal measure. So when we are given a perpendicular bisector, we are given two pieces of information. So let's go with that and let's kind of see how that looks. If I have a line segment, let's say I've got line segment A, B. And let's say that we have a bisector, which we know goes through the midpoint, so we'll say that's the midpoint. And we want to not just have any bisector, we could have a bisector that would go that slant through at any angle, and that would be fine, except if we have a perpendicular bisector, we know that the bisector, the line or the segment that goes through the midpoint, goes in at a perpendicular angle. So we know that the perpendicular bisector goes right through the midpoint and is perpendicular to the line segment. So let's just call this line L. That perpendicular bisector, that line, it could be a ray. It could be a segment. It doesn't have to be a line, but I'm using a line this time. So let's say that we are given over here, what we're given this time is, I'm just going to put G for given this time, we're given that line L is a perpendicular bisector. We're not guessing, we're not saying it looks like one, so we think it's one. We always go by what we know for 100% to be true. And so if we're given it, it's true. So we're given line L as a perpendicular bisector, and then you want to always, always, always mark your figure so that it's very visual, so that you can see what you are given. I'm given that line L is perpendicular, so I definitely want to mark that. And you might be thinking, well, why don't you mark all of them? I could mark all of them. I'm just not cluttering up my page. But I could easily mark all of them because I really know that they're all perpendicular. But if you mark one of them, it kind of implies the rest of them. So that's an angle bisector. That is a perpendicular, and it's also a bisector, which means that's the midpoint, because bisectors go through the midpoint, or they go through, if it's an angle, they form a ray which divides the angle into two equal parts. So if that's the perpendicular bisector, and I'm going to get these out of the way because you can see that they're a little bit distracting to have them there. It's just enough to mark one. Then we know that this segment and this segment, let's call that M. We could call it anything. Let's call it point M. And so we can look at that at a glance and we can see that is congruent to that because they have equal measures, because that's what midpoint means. And then we have a perpendicular, so we know that that's a right angle. So if we're thinking of how we might write that down in a logical manner, let's do it. Let's say our first step, again, would have to be what is given. So it would have to be that line L is a perpendicular bisector, or perpendicular bisector of, we'll be a little more specific, segment AB. And again, how do we know that? It was given to us, so we write given over here. And then at that point in time, we make sure we've marked it, and we have. Okay, so let's start with the perpendicular, because we've got two things to deal with. So if it's a perpendicular, then let's just put 2 there, just for a different number, and this time. So if it's perpendicular, then we know that angle 2 is a right angle. And we know that because of the definition of perpendicular that we've already established. And yes, I'm using abbreviations, and most people do, and most books do. Okay, once it's a right angle, I might like to know, or I do know, so my thinking cap goes and I'm like, okay, next step, measure of angle 2 is 90. And I'm asking myself, how do I know it's 90? I know it's 90 because it's a right angle. See, the step before will always guide me to why I know this and my next steps, because that's a right angle, it's 90. How do I know it's a right angle? Because the definition of a right angle. How do I know it's 90? Because of the definition of right angle. So here we go, definition of right angle. And you might say, well, it looks a lot like we did over here. Yes, it does. And so often it looks like it follows the same steps in order. All right, so we know that that's a right angle. We know its measure is 90. We also know that M is midpoint. And you're like, well, how did you know M was a midpoint? Well, I know it because when we talked about the definition of a segment bisector earlier, we said it goes through the midpoint. And I have a segment, and I have a bisector of that segment. So I know that it has to go through the midpoint. So how do I know that's the midpoint? I know it because of the definition of bisector. Segment bisector. Like, okay, now M is the midpoint. Now what do I know next, logically? Well, I know that the midpoint is the point that divides a segment into two parts that have equal measures. So I could say next that the distance from A to M is equal to the distance from M to B. A to M, M to B. I'm like, well, how do you know that? I know that because that's what the definition of midpoint tells me. So I have definition of midpoint next. And I couldn't say definition of midpoint if I hadn't said already that I had a midpoint. Then you're like, well, what if AM is equal to MB? What is a logical thing that could follow that? Well, if that distance equals that distance, then this segment from A to M, notice my notation now, is congruent to the segment from M to B. You're like, well, how do you know that? Well, we already talked about that is what it means if two distances are equal. It means two segments are congruent. And so the definition of congruent segments are segments that have the same measure. So that is a very logical progression of how our thoughts work when we are given some information and always a drawing, always a diagram to go with it. It might be slightly different in different books and different teachers, but the thought processes will not change. You always want to have a diagram to go with your thoughts. You won't always have to write out a formal list of your steps. This kind of reminds you a little bit of a proof, and so when we get to proofs, they should be quite simple to do because we're already understanding how logically our thoughts must progress and how we have to have reasons for everything. So when you're given a perpendicular bisector, you know two things. You know you have perpendicular, so you deal with that. Perpendicular, right angle 90. And then you've got a bisector of a segment, which gives you a midpoint, which tells you you have two distances equal, which tells you you have two segments congruent. So that is a logical flow of ideas. So spend a little time making sure that you're in complete control of, first of all, the definition of perpendicular. Don't jump from perpendicular and say, oh, I got a 90-degree angle. And you know, I know some of you are saying, well, it's the same thing. I know you are, and it is the same thing, but geometry goes, when you're really trying to do formal proofs and formal thinking, then you don't want to leave out a single step. You really want to be precise. And so perpendicular lines, by definition, say that you have right angles. So you don't want to, so that's what you have to say next. You don't want to jump over that and say that you've got 90-degree angles. You want to go in order. Perpendicular, what does that tell you? Tells you have a right angle. Okay. What does that tell you? It has 90 degrees. That's what it tells you. So as you're thinking, as you develop more and more logical thinking skills, starting with what you know, and then progressing as far as you can, you want to stay as precise and orderly and logical as you can. Later on, when we're doing some problem solving and critical thinking, we can take a few leaps, but not when we're really establishing our groundwork and our foundation about the flow of geometry. I love it. I hope you do too. Know the difference in perpendicular, and notice the difference when you see perpendicular bisector of a segment, that it gives you some added information. So be best friends with these terms. Perpendicular, bisector. Make sure you can spell it. It's a long word. And make sure you know the notations as well. I hope you like this segment. Stay with it, practice it. Don't go any further until you're like really cool with this, and then move forward. Go out and enjoy the day and take a few minutes break. Practice until you are comfortable with this, and don't go ahead until you do. See you later.